All right, today we are digging into something really important. It's a security gap in Microsoft Azure that, honestly, even a lot of experienced cloud pros don't know about. We're talking about a way for attackers to move around inside your environment almost like a ghost. So let's get into it.
Just let that sink in for a second. What if an intruder could stroll through your entire cloud setup, peek into every corner, check every configuration, and map out their entire attack plan, all without setting off a single alarm? That is the exact problem we're going to break down right now.
You know, the whole problem comes down to this thing that security folks call a visibility gap. And it's a fundamental challenge in how Azure is built. See, unlike some other big cloud platforms, Azure just doesn't log every single little thing, and that can create some serious blind spots for your security teams.
This is probably the best way to picture it. Your security logs are great at telling you when an attacker kicks down the door. But what about the days or even weeks they might have spent just looking through the windows, learning the layout of your house, and figuring out the best way to get in? That whole planning phase, it could be completely invisible.
And this really stands out when you put Azure side by side with its competition. If you come from an AWS or Google Cloud background, you're just used to things like CloudTrail logging pretty much everything, both read actions like listing users and write actions like creating a new virtual machine. But in Azure, logging those read actions isn't always a given, and that right there is the crucial difference.
So let's get super clear on what we're talking about. You've got two main types of events. State-changing events, those are the loud, obvious actions that do get logged. Making a change, breaking something. The gap we're focused on is with the read events. This is the quiet stuff, the reconnaissance, the just looking around phase that attackers use to plan their attack before they actually make their move. So you're probably wondering, how on earth does this actually happen? Well, the answer is kind of baked into the architecture of Azure itself. It creates these unguarded backdoors that attackers know all about.
See, you got to remember that Azure isn't one single clean system. It's really this huge collection of different services and APIs that have been built and bolted on over many years. And because they were built at different times by different teams, not all of them were designed to phone home and report their read activities to the main modern logging system.
And a smart attacker knows this. So instead of using the new, shiny, and very well-monitored Microsoft Graph API, they'll intentionally use these older, kind of forgotten entry points. We're talking about the old Azure AD Graph or the Ibiza API that powers the web portal. These are the backdoors. They can poke around using these APIs all day long, and those crucial read events just never get logged. It's like they were never there.
Christian Filipov, a security consultant, really hits the nail on the head. He says these APIs are just their own thing. They're running on their own, separate from the modern logging pipeline. And this isn't some bug that Microsoft can just patch tomorrow. It's a direct result of how the platform has evolved over time.
Okay, I know this sounds pretty bleak. It might feel like you're completely blind here, but it is not a hopeless situation. It just means your strategy has to change. You have to shift your focus from trying to spot someone casing the joint to being incredibly good at detecting the moment they actually try to break in.
Which of course brings us to the million-dollar question. If you can't see them scouting around, can you actually ever catch them?
And the answer is a big, resounding no. Detection is not impossible. Here's the key thing to remember. The visibility gap is for the read-only stuff. The second an attacker tries to change something, create a new user, give themselves more permissions, add a backdoor for later, that action is logged. The attack itself is not invisible.
So what does that actually look like? Well, to stick around in your environment, an attacker has to make some noise. They might add their own phone number as an MFA option on an account they've taken over. Or maybe they'll add a new secret to a service principal to give themselves a persistent key to your kingdom. Or they just assign themselves a super powerful admin role. All of these things are changes, and all of them will leave a footprint in your logs.
So this is the breadcrumb trail that you can follow. First, the moment an attacker acts, your Azure services generate a log. Now, your job is to make sure your diagnostic settings are actually turned on to collect those logs and ship them over to a central log analytics workspace for storage. From there, your security team can use a tool like Azure Sentinel or Splunk to analyze all that data, hunt for weird activity, and find the signs of an attack.
All right, so with all that in mind, how do we get out in front of this? I mean, we can't just call up Microsoft and ask them to fix the logging gap, so the whole game becomes about proactive prevention. It's about building much stronger walls. The logic here is pretty simple, right?
If an attacker can't get into your environment in the first place, then it doesn't matter that there's a visibility gap. The goal is to make it so incredibly difficult to get initial access that any attempt to do so is just loud, messy, and super easy for you to spot.
And that really comes down to 4 things you absolutely have to get right. Number 1, you need rock-solid conditional access policies. This is your top priority. 2, don't forget to apply those same tough rules to your non-human accounts, your service principles. 3, be absolutely ruthless about the principle of least privilege. Nobody gets more access than they need. And finally, double and triple check that all those critical logs are actually flowing into your SIEM so you can analyze them.
And if you're not familiar, just think of conditional access policies as the bouncer at the front door of your cloud. Before it lets anyone in, it checks a bunch of things. Hey, are you on the approved guest list? Are you coming from a location we trust? Is your device secure? Did you prove it's you with multi-factor authentication? Getting these policies right is your absolute best defense.
At the end of the day, the whole strategy is to make an attacker's job as annoying and as noisy as humanly possible. Every extra hoop you make them jump through, whether it's having to compromise a managed device or trying to get around an IP restriction, is just another chance for your security team to catch them in the act.
So I'm going to leave you with one final question to think about. When you look at your own Azure environment, are your security controls really designed to stop an attacker from ever getting that first foothold? Or are you mostly set up to just clean up the mess after the damage has already been done? The answer to that really could make all the difference. Thanks for tuning in.